All right, everyone. This is the last video series that is going to tackle the reciprocals of sine and cosine, which are going to be cosecant and secant. And I'm going to give an example of each and then head on over to the practice. And one thing that we got to remember is that cosecant is the reciprocal of sine, okay, and vice versa. And so, so that means is that what we're going to do, the technique that I'm going to show you is that we're going to graph the sine graph first, and then we're going to make some connections between that and the cosecant graph, and then we're going to go ahead and pick this thing apart so we can have a better idea what this is going to look like. So anyhow, let's get the sine graph on first. Okay, so there is sine, just kind of like a ghost of it, if you will. Now, we're after cosecant, which is reciprocal. So what we're going to do is that we got to think about each one of these x-intercepts here, okay, are, of course, is going to be where x equals 0. However, when we take the reciprocal of 0, that's going to be undefined. So for cosecant, every one of these x-intercepts are going to turn into asymptotes, okay? Just like these guys right here, okay? And for cosecant, since we're taking the reciprocal, that's going to flip the values, and so therefore it's going to flip the actual sine part, or the valleys and peaks, like this here. And it is going to go right towards the asymptotes, of course. So it's going to look like some horseshoes, if you will. Okay, or some people call them teeth. Okay, I don't know anybody who has teeth like this, though. But and then that is going to be the graph of cosecant in just its parent position. Okay, so I'm going to erase everything that we don't need, which is the old part of the sine graph. And there we have it. And so let's go ahead and take a look at what we got going on here. Okay, so the amplitude, it's not really a amplitude here, but it was the single distance between the peaks and valleys here of the graph before we flipped it, and the absolute value of that. So that's just going to be 1. The period is going to be the exact same as the sine graph right here. Okay, if we look at this box, it starts to repeat itself after that. So that is really kind of like one good periodic example of the cosecant graph here. So that's going to be 2 pi, the same as its reciprocal sine. Phase shift, we're not shifting anything right now, but it works the exact same thing as sine, so keep that in mind. And same thing with the vertical shift. X-intercepts, hey, there aren't any, okay? So that means is that it doesn't hit at all in its parent form. Y-intercepts, and there's an asymptote right here on the y-axis, and so therefore there is none there as well. So now what we need to do is that we need to formulate the domain. And the domain is going to be all real numbers, except, and x equals, and so we have this distance of pi in between the asymptotes here. So, and since the first intercept, or I should say the first break in the domain is at 0, we just use pi n, where n is an integer. Okay, and so that means is that every increment of pi from 0, okay, so this would be like 1 pi, 2 pi, again, 3 pi, whatever n is, we can go ahead and say that there's going to be a break, and this would be like a negative pi going back, -1 pi, etc., etc. And then the range, interestingly enough, is going to be basically the opposite, everything that sine is not. So it's going to go from a negative infinity, okay, which is starting way down here at the negative infinity part. And it goes up to a -1, okay, at these guys right here. And it includes that -1. Then we have kind of like this break right in the middle here. So we have to union that and then start back up at 1 and then go to infinity. All right, so that is cosecant and its parent form. And so let's take a look at graphing it and shifting it around and doing all that good stuff. So see you in the next video.